you all are doing well. In this section of my video, I'll be going through the concept of components of circuit diagram, which is a topic of again chapter 12 electricity class 12. In my previous video, I had explained you the concept of circuit diagram. Okay? So here what a circuit diagram consists of, or what different kind of elements you need to connect in a circuit diagram to make your circuit complete is represented in a table given below. Now, while making any circuit diagram, you should keep in mind that different elements which you are using for connection of circuit should be drawn properly. They should be properly labeled. While explaining or by explanation, whatever instructions or symbols are necessary, you should keep those symbols properly. Now, starting from the very first thing, as you can observe, there are total of 10 circuit elements which are used to make a circuit diagram. It is not necessary that at a single time we need all these circuit elements. Depending upon our circuit requirements, we can use these multiple components. Now, let us to start with. The very first is an electric cell. We can also say this as a battery. A battery consists of two terminals. As you can see the symbol very clearly, it has two symbols. One is positive and another one is negative. While drawing a symbol, it should be kept in mind that the positive symbol, positive terminal, is a bit bigger than the negative terminal. Going towards the another concept, which is a battery. So you have just studied an electric cell. As you observe the battery here, if you combine multiple electric cells, you will make a battery. This can be done at home also, in practical purpose also. If you take multiple cells and correct in the order as you have shown in this diagram, you can obtain a battery of much higher potential. But how? While connecting a battery, it should be noted that the positive terminal of second cell should be connected to the negative terminal of first cell. Similarly, positive terminal of third cell should be connected to negative terminal of second cell, and so on, depending upon the magnitude of battery required. So a battery is a combination of electric cells, as you have observed. Now the third component is a plug key or your switch. As you can observe, a simply true brackets. Now this represents an open switch. If I put a dot here, it represents a closed switch. I am again showing if there is nothing between the two brackets, this bracket represents a open switch. If I put a dot here, it represents a closed switch. So in order to complete your circuit diagram and allowing the electric current to flow in a circuit, you should keep in mind that if a circuit contains multiple number of switches, all the switches should be closed. Fourth point, a wire joint. Now this is very important, wire joint and a wire crossing without joining. As you can observe these two figures simultaneously, you will say that the joining is represented by a simple dot, while its crossing is represented by a loop. So if you find a loop at any place, you should be clear that there is no connection between these two wires. While if you observe a dot at the assembly of two wires, you should be sure that these two wires are joined. Similarly, a loop representing that the wires are not joined and the one wire is crossing the another wire. A component, electric bulb. Very simple symbol of electric bulb shown here. You should be very careful while drawing the symbol of such elements. Now, the most important, resistance. A simple wavy line represents a resistance, as resistance is represented by R. Another component, a variable resistance or a rheostat. Now there should be no confusion between a resistance and a variable resistance. A variable resistance is that resistance whose value can be varied. I am again repeating, a variable resistance is a resistance whose value can be varied, while the value of a simple resistance cannot be varied. Therefore, if you observe a wavy line with an arrow over it, this represents a variable resistor. Another symbol of variable resistance is here. Another name for variable resistance is rheostat. Moving on to the measuring instruments which are connected in device, the very first is an ammeter. Now moving on to the measuring instruments which are connected in a circuit across large number of devices for measurement of various values. The very first is an ammeter. An ammeter is represented by letter A inside a circle as shown in figure. Now this ammeter is a device which is used for measuring electric current. So in order to measure the electric current across any instrument, you should connect ammeter. This ammeter should always be connected in series. I am repeating this point, it is very important where to connect such elements. An ammeter is always connected in series across the device or across the element in which you wish to measure electric current. The very last component is a voltmeter. As you have just gone through that ammeter is used for measurement of electric current, here is another component, voltmeter, which is used for measurement of potential difference, represented by letter V inside a circle. Now, in order to connect a voltmeter, you should keep in mind that voltmeters are always connected in parallel. That is, if you wish to measure potential difference across the ends of any element, you need to connect voltmeter, or if you wish to measure current, you need to connect ammeter. But the most important thing is ammeter should be connected in series while voltmeter is connected in parallel. So this was the simple discussion of all the various circuit components which are necessary in making a circuit diagram. I hope with the help of this video you will be going through this topic very well. Thank you.